Hey everyone, Dan here from Faktory Studios. In this video, we're going to build a simple enemy manager together. We'll start with one short script that just spawns enemies. Then we'll improve it step by step, first adding a list to keep track of them, and finally using an array for fixed spawn points. By the end, you'll understand when to use lists and when to use arrays. Let me run you through this scene I have set up here just in case you want to try and replicate it. So I have a ground plane here with a checkerboard pattern assigned in the material here. You can see the default checker gray, and then I've just tinted it blue with the base map color there, and I've tiled it 100 by 100 in the X and Y, and the ground plane is also scaled to X10 and Z10. And that's about it for the ground plane. Now, I also have some fog assigned. If you hit Control 9, and you'll get the lighting window. And in here under Environment, you can assign the fog, and here you can see my settings. And I've also set a solid background color on the camera. And under Environment, I just set it to solid and selected the same color as my fog. And finally, I have a zombie prefab, which I've downloaded from Mixamo. Okay, if you want to have this scene, you can certainly find it on my Patreon website. The link is in the description below. All right, so we're going to start by creating a script, and this script will manage enemies. So the first thing we're going to do is have it create a lot of enemies for us when we hit the space key. So we'll go ahead and right click on the scripts folder, go to create and mono behavior script. And we'll call this enemy manager. Right click in the hierarchy and create an empty game object and call it enemy manager as well. And we'll assign the enemy manager component to our enemy manager game object. Okay, and then I'll double click on the enemy manager component to open it in Visual Studio. All right, we're gonna start by deleting the start method. Now, like I said, we're gonna need a reference to a enemy prefab. So we're gonna create a variable here to store that reference. So let me type that out and then I'll explain it. So we have a serialized field attribute here, and that basically makes a private variable visible in the inspector window. Then I've assigned it the data type of game object, which is what our enemy prefab is going to be. And then I've named it enemy prefab with the underscore here. The underscore just implies that this is a local or a class variable that's not public. The next thing we want to do is we want to poll for keyboard spacebar presses. We'll go ahead and write that out. So now you can see here that I've created a conditional statement, this if you've watched the previous videos, you should understand what that is. So basically just if this is true, then do what's in here. If Keyboard.current, and you can see as I was typing this, if you were paying close attention, Visual Studio added this using statement up here, using Unity Engine.input system. Okay, so this essentially, you can read this just like it is. Keyboard.current space key dot was pressed this frame. So that just says, was this space key pressed this frame? If so, do whatever's in here. So that's what's happening here. So then we say instantiate. Instantiate is a method in Unity to clone a game object and put it in your scene. And there are a lot more parameters you can add to this instantiate, but in our case, we're just using the enemy prefab as the parameter. So the game object is what we're instantiating, but there are plenty more. Okay, so let's go and see this in Unity. All right, so when we jump back into Unity, you can see our enemy manager now has this enemy prefab slot available. Remember, we use the serialized field, and then we can just drag our enemy game object into this slot. Now let me show you, if you don't have my scene, how to create your own enemy game object or prefab. So we'll right click in the hierarchy, we'll go to 3D object, and we'll select capsule. And then we can call this enemy, and let's just reset its transform, position and scale, and I'm going to move it up to 1 in the Y. Now with that done, I can just drag this game object into the prefabs folder in my project window, and that creates, you can see here, a little box that says enemy. You can also see here in the hierarchy, enemy is now blue and it has a right arrow, and you can double click on it and then edit it in isolation mode here. Okay, so once we have our enemy prefab, we can delete the game object we have in our scene. Okay, so let me assign my enemy prefab, in this case I'm going to use my zombie, into the enemy prefab slot, and then I'll hit play. Okay, now in the game window, you can see we've got the game window open. I'm going to hit space, and we should see an enemy appear. So you can see here in the hierarchy, we've got a zombie idle clone appearing. And you can see there that we've got our idling zombie just kind of sitting there. And if I hit space again, we've got another idling zombie, and I can just continue to hit space and I have more and more zombies there. Well, right now these enemies exist in the scene, but our code has no idea that they're there. And that's the problem we're going to solve. So So to fix this, we're going to need somewhere to store those spawned objects, and that's what a collection is, a container that can hold multiple values. Instead of a single game object, we want something that can hold many game objects. So in C#, there are lots of collection types. There are arrays, lists, dictionaries, queues, stacks, and hash sets. But arrays and lists are the two that you'll use most often. So let's jump into our enemy manager script and let's implement a list. Okay, so you can see I've added this new line here. Again, serialized field attribute to make it public in the inspector. And then it's a private variable and it's called list, and it's a list of game objects. You can see that in the greater than, less than symbols. And then I've called it underscore enemies. Again, the underscore just to imply that it's a local class variable. Now, unfortunately, we have this red underline here, and you can see up here that I have two new using statements, and both of these are wrong. We don't actually need either of them. So let's delete those, and we can right click on the list keyword and go to quick actions and refactorings. And you can see the first recommendation up here is using System.Collections.Generic. And what that's doing essentially is saying that we need to know how list works. And in order to do that, we need the namespace where it's located. And so C# stores the list class in the System.Collections.Generic namespace. All right, so with that done, now we just want to store our enemies in that list that we've created. So let's go ahead and do that now. You can see here that I've added some new code here to the instantiate line, and basically I just said var enemy equals and then instantiate. Now instantiate returns a game object, so when you call instantiate, it clones this object, but it also returns it. If you do have a variable to store it in, then it will store that game object in the variable. And the keyword here var just means take whatever game or whatever data type the element on the right side of the equals returns, assign that to my new variable that I'm creating here. So essentially this enemy variable is now a game object data type variable. And then I take enemies, the list that we've created up here, and I just call the add function on enemies, and it just adds the enemy to the enemies list. All right, so let's go see this in action in Unity. All right, so I don't need to do anything here, but you can see already in the inspector that I've got this enemies list. So let's go ahead and hit play and test this. All right, so as I hit spacebar, you can see the enemies list here is growing. And it grows each time a new zombie is cloned into our scene. So that's the beauty of a list. It's a resizable container built on top of an internal array. It automatically grows when you call add, and it shrinks when you call .remove or .clear. All right, so that's great, but let's see how we could potentially remove objects from our list. So let's go to Enemy Manager again. So let's use our list to interact with those enemies. We'll add a method to destroy an enemy when we click it. So I'm going to update the update method. Essentially, we're going to use the left button mouse click to try and shoot a ray at an item in our scene and destroy it. So let me write that out. Okay, so you can see here I'm calling another conditional. So if this is true, which in this case, if Mouse.current left button was pressed this frame, then we'll do everything that's inside these braces. And so first we do a camera main screen point to ray, and we give it the mouse's current position. So screen point to ray, as you can see here, it returns a ray going from the camera through a screen point. So the screen point is in 2D, and screen point to ray generates a ray in 3D space that again takes the mouse's current position in your screen and then shoots a ray from the camera's position to that mouse position. And then it assigns it back to this ray variable. And then we check again, another conditional here, if physics.raycast. So this allows us to shoot that ray that we created and then see if it collides with anything. So we say physics.raycast, we send in the ray, and then we use this special keyword out. So this basically takes this variable here that we haven't defined anywhere, and it fills it with data without us defining it, and it allows you to use it within the local scope here. So out variable, again, it's sending in something that we haven't defined. We could define it, but if you just roll over, you can see this hit is returning a raycast hit data type. So that's what gets created here when we use the var keyword. And then we also check if our enemies list removes this game object. So we check the hit, which is stored here, .collider. So that's the collider on the object, and then we check the game object for that object that has that collider. And we try and remove it from the enemy's list. Now, lists are smart enough, they can run through and compare all of the elements within the list with the element that you feed it and see if it can find an exact match. If it does, then remove will prove true. If it doesn't, it will prove false, and then this code will not be run. So if for some reason we have a reference to an object that's not in our list, or if we've hit something that's not in our list, then this won't proceed down here. So then finally we use the destroy method. Okay, so let's go back into Unity and test this. All right, so I'm gonna hit play, and let's just select our enemy manager so we can see it. All right, so I've added a new zombie, and then I'll just click and you can see it got deleted. So if I add a couple of these, I can click and you can see that they get deleted from the list there. But what if we want to control where the enemies spawn? Maybe we want 4 specific spawn points around our map. A list would work, but we don't really need to resize it. Those points never change. So that's where arrays come in. All right, so let's add another field here. Okay, and then we'll add a simple index counter as well. Okay, so if we look at this line again, we're using the serialized field attribute to make it visible in the inspector, and then it's private so other classes can't access it. And then we're using transform, but we have these special brackets here. So these brackets essentially say that this is an array of transform. As an array, it's now a special data type that stores multiple transforms. And again, we're calling this spawn points with the underscore in front of it to denote that this is a class member. And then we down here assign a private integer index with, again, the underscore there. And now we're calling it private, and notice we have not added the attribute serialized field here. And so that makes this private invisible to the inspector. All right, so now let's add some magic here. Okay, so we've added a couple lines here. This var point now is pointing to whatever's in spawn points, and then in the brackets here, we're actually calling a number. So it's index modulo spawn points.length. Essentially, this gives us a way to iterate through the spawn points over and over using the underscore index and incrementing it. The plus plus here just says that make index equal index plus 1. So every time you hit the space bar, index will increment by 1. And then up here in the spawn points, it will essentially take that index number, divide it by spawn points, and return the remainder, and use that as the spawn point to spawn our new enemy prefab, which you can see we've also modified the instantiate. And as I mentioned earlier, instantiate has multiple overrides here. So if you're rolling over instantiate, you should be able to see it says 12 overloads. So these overloads here allow you to add more parameters or less parameters, and you can always go to the documentation and see what the other overloads are. So we're assigning enemy prefab, then we're giving it a point position and a point rotation. So it's going to drop our new clone into that position at that rotation. All right, so let's go into Unity and test this. All right, so before we play, you can see the enemy manager has a new field which says spawn points, and the list is empty right now. So we want to define some spawn points so we actually spawn them in positions. Otherwise we'll get errors because we haven't done any error checking to make sure that our spawn points isn't empty. So let's go ahead and right click in the hierarchy. We'll go to create empty, and I'm going to call this spawn points. And I'll just zero it out by right clicking on transform, hitting reset, and then under spawn points I'll create a new empty object, and I'll call this point 1. And I'll just move this somewhere arbitrarily. And then I'll duplicate it by hitting Control D, and I'll rename it to point 2. And then I'll move this one, grab point 2, and I'll move this over here. And let's get 4 points in here. So I'm just going to move that back here, and then one more, and maybe I'll put it right there. And let's rename those. So 3 and 4. Okay, now we'll select our enemy manager and we'll hit this little lock button on the top right of the inspector window. And that allows me to leave this inspector locked in the window on the enemy manager. And I can just control click or shift click. So I can click the first one, hit shift, and click the last one. And then I can drag all these guys onto the label spawn points, and that automatically populates them into that array. And then I'll unlock this and just click on enemy manager there. Okay, and before we hit play, I'm actually going to make sure that my enemies are sitting within the camera view. So I see here that I have actually placed the enemies out of the camera view. So let me just select the camera, see where the view is, and I'm going to grab point 1 and just drag it over here. Point 2, and I'll drag it over here. Point 3. We'll drag it over here. And actually, we can make this a little bit easier. It's kind of hard to tell here where these points are. So let's grab all of these guys. And up here in the inspector, make sure to uncheck that. In the inspector, you can see this 3D box here, the drop down. Let's select these diamond shapes. And I made them blue, but you can select any color you want. So then we can go in our main camera and just make sure that they are sitting in the camera's view. So it does look like they are. I'm just going to scoot them a little closer to the camera. Maybe grab this one and put it over here. Okay, so now we should be able to test this. Let's go ahead and hit play, and I'll select my enemy manager so we can see it in here, and I'll hit spacebar. Okay, so there's 1, there's 2, there's 3, and there's 4. That's great. Okay, let me go back in to these points and see if I can just rotate some so we can see the rotation. All right, so let's hit play now, and I'll hit spacebar. And there you go. It looks like they're rotated and they are appearing. And I can continue to hit spacebar and it's duplicating. It's duplicating more zombies on these spawn points. But you can see now it's all working properly. And I can just click and start deleting them. You can see, there we go. There's only one there now. All right, so you could see in play mode, each press of space key was creating one spawn at each spawn point, and it was iterating through each spawn point and then going back to the original spawn point to start over. So arrays, just so you know, are fixed in size collections. It means that they are faster to index because of this. So C# or the compiler will dedicate memory in contiguous space, so one after another, so that it can access each element in an array quite quickly. But because of that, the array elements are fixed in size when you first hit play. So if you have 4 elements, when you hit play, that's what you're going to have in your array, unless you delete the array and rebuild it. And that's kind of what list does under the hood. What's so great about arrays is that they're extremely fast because of the memory allocation. All right, so let's compare them quickly. So arrays, again, they're fixed in size, they're fast to access, they're great for known slots, and lists are dynamic in size, they're flexible and easy to modify, and they're great for runtime objects, but they can become less performant. So you use arrays when the number of elements is constant, and you use lists when things are changing during gameplay. So beyond these, C# gives us many more specialized containers. So there are dictionaries for key value lookups. There are queues for processing tasks in order. There are stacks for things like an undo system. You can save commands and then reverse them. There are hash sets for tracking unique items. So we'll explore those in future videos, but it all starts here with arrays and lists. Now we can spawn, track, and destroy multiple enemies cleanly. You have a general understanding of what an array and a list are and when to use each one. Drop any questions and comments down below in case I missed anything. If you found this helpful, hit like and subscribe so you don't miss the next episode. Also, I've added reference to C# documentation down below for both lists and arrays and collections if you want to do some more research on your own. If you want to grab this project, you can get it on Patreon. The link is in the description below. Okay, it's time to call out my amazing Patreon supporters: ES Claus, Malik, Ian, Hunter, and Benson. Thank you guys so much for your support. It really means a lot to me. Thank you guys. If you want to build games from scratch, check out my Unity 101 course. All right, thanks for watching, and now you know how to keep track of multiple enemies in Unity using C# collections. I'll see you guys in the next one.